Illustrative Math, Algebra 2, Unit 6, Lesson 4 is called the Unit Circle, Part 2. All right, so our goal today is I can find different angles on the unit circle and estimate their coordinates, and I can find exact coordinates of any angle that is a multiple of 30 or 45 degrees, or I guess in radians, it'd be pi over 6 and pi over 4. Okay, so just know, and you haven't really learned why yet, but pi over 6 is 30 degrees and pi over 4 is 45 degrees. All right, so what do you notice? What do you wonder? Take a minute, pause the video, and look at this image and come up with some things that you think, that you notice and that you wonder. Okay, so we're going to start with the notice. So I already wrote them down. So it looks like a wheel. Might be a wheel, or you might call it a pizza, or you might call it a pie. Okay, looks like I have equal slices, and every slice is actually called a sector. Okay, every slice is called a sector. Okay, it looks like it's divided equally, but then I don't know. Maybe it's not. I don't know. If I were to take this angle here and kind of trace it, let's see here. If I rotate that down here, yeah, it looks pretty much the same. So yeah, I guess it is equal. Looks like they're equal. We don't know for sure, but all right. So each piece looks like it's pi over 6 radians. So it looks like this is pi over 6 radians, pi over 6. How do I know it's pi over 6? Because if you look at the half circle here, if I look at half a circle right here, it looks like I'm divided into 1, 2, 3, 4, 5, 6. Half a circle or a semicircle is pi radians. So if I take pi divided into 6, that would be pi over 6 for each one of those. So this angle here, let me do a little erasing here. So like this angle to go right there, this is 2 pi over 6s. So it's like 2 pi over 6s with 2 times pi over 6, which would be 2 pi over 6, which if you reduced it, this angle right here would be pi over 3 because 2 and 6 are both divisible by 2. Okay. And then like maybe if we wanted to go to this angle right here, that would be 1, 2, 3 pi over 6s. So 3 times pi over 6 would be like that. Move it up here. And then if I reduced that, these are both divisible by 3. That would be 1 and 2. So this angle is actually pi over 2 right here with the green. So a little bit of stuff there. I'm kind of just opening it up for discussion. If I were in a classroom with a bunch of students, we'd kind of piggyback off of some of this stuff and have some good discussions. Okay, so all right, let's go on to some wonders. So I wonder, are the angles of each sector the same? Okay, so I guess I made an assumption that they were each pi over 6, but it's not marked. So, we don't know if they're exactly pi over 6 or if they're just, really close. Okay, so that would be maybe a wonder too. Like, are they exactly pi over 6? All right, what are the units on the grid? So, you count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get here. Are each of these 1? Are each of these 2? Are each of these 0.1? We don't really know. And what's each angle measurement in degrees? Well, I kind of already told you on the goal slide. I said pi over 6 is equal to 30, right? You'll learn why later on in this course, but so like this angle here, if I wanted to put it in degrees, that's 30. This would be 2 times 30, so that'd be 60. This angle right here, that'd be obviously 90, and you can kind of tell that it's a right angle. So you can just count by 30s, or you can count by pi over 6s as you keep going. That is assuming that they are all pi over 6. All right. Here is a circle with a radius of 1 and some different radii drawn. Now, You can't really see the angles here. I'm going to make them a little bit. I'm going to rewrite them so you can see them a little bit better. This one is, what is that? 5 pi over 12, I think. Got cut off when I put that slide in there. That is, let me take a look. 5 pi over 3. Sorry about that. All right. So draw and label angles with positive x values as the starting ray for each angle, measuring pi over 12, pi over 6, pi over 4, all the way to 2 pi. So basically, you start out with pi over 12. Pi over 6 is really 2 pi over 12, which reduces to pi over 6. Then we go to 3 pi over 12. And again, this reduces because 3 and 12 are both divisible by 3. This is 1 pi over 4. It's kind of like I just cancel the divide them each by 3. So then we're going to get to 4 pi over 12. So that would technically be pi over 3. So basically, if I have pi over 12, that means you're going to take this half circle here, okay, this semicircle here, right here, this semicircle, and we're going to divide it into 12 equal slices. So basically 4 in this quadrant and then 4 in this quadrant, okay? We're going to do the same thing down here. So you're going to end up with 24 total angles. Now, how do you know how big to make them? Well, if you look here, this is 13 pi over 12. So if you look at this angle right here, it's like really saying like 1 pi would be to get to this point, plus another pi over 12 would give me 13 pi over 12. So really this angle is kind of like this slice right here. I'll color it in here in green. This slice is basically, the same slice that you're going to have for all the way around. So there's one, there's another. All right, you're just going to kind of go all the way around and fill it in, okay? So try to divide these equally. What I would probably do if I was going to do this in my book, this is a 45, I'd divide these in half, and then I would maybe start here by dividing this in half and splitting that, and then splitting from the 90 to this green one that I drew, maybe like right there, because this one's not quite there. Split this in half. You already got that in the middle, like that. So anyways, as you go and do that, I put one that's a little bit neater here. And we have that just like that. So if you notice here in the half circle, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in a semicircle right there. And then the other 12 down there. And basically we just counted by 1 pi over 12. And then, sometimes we reduced them and got different numbers. Okay. All right. Label the points where the rays meet the circle for which you know exact coordinates. So we're going to see which ones are exact. So that's obviously exact. That's, say how long the radius. The radius is 1. So every grid line is basically going to be 0.1. Okay, but this point here is 1, 0. This point here is 0, 1. This point here is -1, 0. And this point here is 0, -1. Okay. So you might look at this and you might try to say, oh, well, this point here, I know that's, 1, 2, 3, 4, 5, 6, 7, 0.7. And then you go up 1, 2, 3, 4, 5, 6, 7. You might try to, say that that point is 0.7, but we don't really know for sure. We don't know if it's like slightly off. It looks like it's on the corner there, but we don't really know. So I'm not going to put that. I just know if the radius is 1 unit, though, from here to here, this has got to be 1 to the right. Same thing here. If I swing my radius up 1 unit, right there, that's 1, 0, 1. Same thing there. So I know those 4 for sure. I don't know about the other ones yet. All right, so if we were in class, I'd assign different groups, like different quadrants, okay? We're going to kind of do it all together here. So we're going to kind of estimate the points, okay? Estimate the points where the angles intersect the circle, okay? So we already knew a couple of these. We knew this was 1, 0. We knew this is 0, 1 right there. I'll just rewrite these because I already had that on the last one. All right, so now we're going to estimate the points right here. So that point is going to be, we're going to say, I don't know, maybe like 0.97. And then it looks like I go up 0.26, maybe. And then we go right here. Let's do that in a different color. Let's do that in blue. This one looks like I go to the right 0.8 something. I'll say 0.87. And then it looks like I go up 1, 2, 3, 4. So hard to tell. It looks like it's actually right on that line. Maybe it's 0.5. Let's just say 0.5. And then we'll go here to this point. Looks like I go to the right a little bit more than 0.7. And then it looks like I go up the same amount. So I'm just estimating this, okay? You might be slightly off, okay, if you pause the video and try to do this yourself. Let's see here, this point. Looks like it's a little bit more than 8. Not quite to 9, so I'm going to say 0.87, maybe 0.88. And then this one looks like to the right. Looks like it's exactly at 0.5. So I'll go there. And then the next one will be right here. Kind of looks like the same as this. It's just your X and Y's are switched. So I'm going to say a little bit over 2. I'm going to go 0.26. And then I'll keep the same Y value, 0.97, because it's just a little short than 1. Okay. So what you should notice here, and I use different colors on purpose, if I look at all these points, I should be able to move them, okay? So like this one, it's the same X value, but the Y is negative. So whatever I estimated here, I'm going to keep the X the same. Oops, change the Y to negative, okay? So I'm going to do that here, which would now allow me to this point. Looks like I move the X to the left. Actually, let's do this one first. The Y coordinate stays the same. So the Y coordinate here is going to be 0.26, but the X coordinate is negative. And it looks like I go the same distance that I went right, but just to the left. So then down here, they're both going to be negative. It's the same, really the same distance away here. Okay, so what you should notice is these 4 red points, they all stay the same. They just change signs. All right, so let's go to the blue one here. So if I come down here, this is the same X coordinate, but your Y coordinate changes. If I come over here, same Y coordinate, so I'll keep it at 0.5, but the X coordinate's negative. If I go down here, they're both going to be negative. Okay. Same idea here. This is going to be same x-coordinate, but a negative y-coordinate. Negative x-coordinate changes to negative. Y-coordinate's the same height, so it stays the same. And then down here, they're both going to be negative. Okay. Go to the orange one right here. 0.87, negative 0.5. Change the sign of the x. So this is going to be negative 0.87, still positive 0.5. And then down here, they're both going to be negative. And then the last one that we have, this is going to be a positive 0.26 and a negative 0.97. Negative 0.26, positive 0.97. And then down here, they're both negative. Okay, so kind of cool. You see the symmetry there with all the different points on that unit circle. We're just estimating it. Over here I have all the numbers. Oh, shoot. Hold on. So as you look at your table here, if you see it in a table, you can kind of see all these points. I'll just highlight a couple of them here to show you. So like, let's do the pi over 3. Pi over 3 would be right there. This is 2 pi over 3. So 2 pi over 3 is right here. Okay, and then this one here is 4 pi over 3. And then the last one here is 5 pi over 3. So as you look at those, you can see it's just the positive and negatives that change signs as you move from quadrant to quadrant, okay? And it's important to know quadrant 1, this is quadrant 1, this section right here. And they use Roman numerals. This is quadrant 2, quadrant 3, and this is quadrant 4, okay? I don't know why, but quadrants are always used, they always name quadrants with Roman numerals. All right, so let's talk about exact values of pi over 6 and pi over 4. So if I were to here have this angle here as pi over 6, okay? Really what you have here, and I told you this earlier, pi over 6 is really a 30-degree angle. So if I were to drop this down and make a right triangle, this would be 60, and this would be my 90. Now, if it's a unit circle, the radius is 1 unit. But we want to know what the x and y coordinate is. So the x coordinate right here, I'll use red, is this side length on my triangle. And the y coordinate is that side length on my triangle. So if you think back to geometry, you got your special right triangles, your 45, 45, 90, your 30, 60, 90. If I have a 30-degree angle, if I want to find the short leg and I know the hypotenuse, I divide by 2. So because this is 2x and this is x, so if I want to go that way, divide by 2. So this is going to be 1 divided by 2, 1/2. If I want to find the long leg, and I have once I know that short leg, I'm going to multiply that by radical 3. So it's going to be 1/2 times the square root of 3, which is just going to be radical 3 over 2. Okay, so now we can get some exact values for, really, it's 30 degrees, but it's really pi over 6, essentially. Okay, let's go to the next one. Let's go to the 45. So here's my pi over 4, and I draw a right triangle there. So remember, pi over 4 is 45, so it's kind of like this angle is 45. if I were to want to find the coordinates, again, the x coordinate is this side of the triangle. Again, remember your radius is 1. The y coordinate would be this side of the triangle. So on the 45, 45, 90 triangle, because that's 90, if I know the leg, I multiply by radical 2. If I know the hypotenuse, I have to divide by radical 2. So really this is going to be, I'll do a little scratch work over here, 1 divided by radical 2, and then I have to rationalize that, so I get radical 2 over 2 if I wanted to simplify that. And then the y coordinate is going to be the same, because if you look here, it's x and x. It's an isosceles triangle, so I don't really need to do any work there. I can just plug that in because I know it's the same. All right, so let's go over here to the last one. So again, same thing here. This side of the triangle is going to be the x coordinate of the point, and this side is going to be the y coordinate. So I come up here, I put my parentheses. So remember, radius is still 1. If this is it's 2 pi over 6, this is really pi over 3, okay? Because really, this was pi over 6, and then this was pi over 6. If I add it up, it's really 2 pi over 6. Okay, so I'm going to write it as 60 instead of pi over 6. And this would be my 30. Okay, so if I want to find the x coordinate, divide by 2. I'm going here. I want to find going from hypotenuse to the short leg, the leg opposite of 30. Divide by 2. This is going to be 1/2. And then for the y coordinate, the long leg, once I have the short leg, if I divide by radical 3, I can get there. So it's kind of the same thing I had here. Just do it in blue, or you times it by radical 3. I'm sorry, 1/2 times the square root of 3. That gives me radical 3 over 2. All right, so now we can kind of move all these points here. If you want, just change the signs. So like over here, this point, we just kind of learned that is negative 1/2 radical 3 over 2, negative radical 2 over 2, radical 2 over 2, negative radical 3 over 2, 1/2. You're just changing the x coordinates. We already knew those. 1, 0, negative 1, 0. And then over here, same thing like I did over here. I just changed the sign of the y coordinates. So this point, I move it down here. Radical 3 over 2. Negative 1/2. This is going to be positive radical 2 over 2. Negative radical 2 over 2. And then this one, positive radical 3 over 2. Negative 1/2. And then over here, they're both negative. So oh, wait, I screwed that up. I copied the wrong one. I did them backwards. This would be this one here. Whoops. And then this one would be the same as that angle because it's a 60 there. So this would be negative 1/2 negative radical 3 over 2. Okay, so eventually you're going to have to memorize all these values here on the unit circle and know the angle and all that stuff. But I just wanted to kind of show it to you here while we were doing this, because that's going to come a little bit later in this course and is really going to be important in a pre-calc or calculus class. All right, so our last thing here is our cooldown. So here's a unit circle, so that means the radius is 1 unit. Angle QPR has a measure of pi over 12, so this angle right there is pi over 12. So then they tell you the coordinates of the point. Angle QPT is 11 pi over 12, so that means this angle here is the same as that. This is a pi over 12 angle with the x-axis right there. So the coordinates, the y-coordinate is going to stay the same. The x-coordinate will be negative, though. And so it's going to be negative 0.7 and then positive 0.26. And then this is 13 pi over 2 to get all the way to there. Okay, so that angle QPU. So this is really like, again, here, this is a pi over 12 angle with the x-axis. So this is going to be kind of the same coordinates, just they're both going to be negative, okay? So hang on, let me put that first one in there so you can see it. So there you go. Now, if they ask you to find this one here, this would be like, a little off there, maybe more like there. That would be 23 pi over 12 because you're just 1 pi over 12 short of the full 2 pi. That one would be, just for the heck of it, we'll do it, change the sign of the x coordinate. All right, so hopefully you enjoyed this video, and thanks for watching. We'll see you next time.